Let's go to page 542, and this is lesson 8.5. This lesson is to use properties of trapezoid and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are the bases. Okay, so quadrilateral with one pair of parallel sides is trapezoid. And trapezoid, the parallel sides are called base. So this is the base on the top, base on the bottom. Okay. A trapezoid has two pairs of base angles. For example, trapezoid ABCD, angle A and angle D are one pair of these base angles, and angle B and angle C are the second pair. The non-parallel sides are the legs of the trapezoid. So this is the base, this is the base. The base are the one that's parallel. The one that's not parallel are the legs. Okay. So let's go to example 1. Use a coordinate plane. Okay. So it says show that ORST is a trapezoid. So you have this over here. So compare the slope of opposite side. Again, remember, definition of trapezoid is you have one pair of parallel lines. And if the lines are parallel, they will have the same slope. Okay? So when you sketch it out, it looks like these two sides are parallel, but to verify that, you have to find the slope. So the slope, okay, so you can use the coordinates. So you have the 4 minus the 3, okay? So you can, that's your x2 minus x1 over the y2 minus y1 over x2 minus x1. So that's your formula. So make sure you remember your formula for slope. So again, slope equal to y2 minus y1 over x2 minus x1. So make sure you memorize this. You're going to use this a lot. Okay? So that's what this is. So that, again, that's your y2 minus y1 over x2 minus x1. And you work out the math, you get 1/2. Okay? Now you do the same thing for slope of OT. So you got y2 minus y1 over x2 minus x1, and you get 1/2. So since they have the same slope, then they are parallel. And since they have one pair of parallel lines, then therefore it's a trapezoid. Okay? Now instead of using the formula, when it's giving the when it's giving in the grid, a lot of times it's easier if you look for the slope of RS. Okay? So from R to S, you go up 1. So you go up 1, so that's 1, you go over 2. See? 1 over 2. So you do the Y first, right? Y is up and down. Okay? Whereas over here, the slope of OT equal to, so from O to T, you have to go up 2 over 4. So you have to go up 2 over 4. Okay, see that? So these are the same, right? See the 2 over 4? Okay? So you can either using your picture, the graph, or you can use the coordinates. Okay? So if the picture is giving, I like to do it this way because it's much faster. You don't have to mess with numbers. So you just go up 1 over 2, right? Up 1 over 2. And this one you go up 2, right? So you go up 2 and you go over 4. So again, this is the up and over. So this is the Y and this is the X. Okay? Okay, so again, make sure you know how to find the slope. You're going to use that a lot. Okay? Okay, now let's go to page 543. Isosceles trapezoid. If the legs of a trapezoid are congruent, so if you have two legs are congruent, then the trapezoid is an isosceles trapezoid. Okay, so here are some theorems. So theorem 8.14. If a trapezoid is isosceles, okay, then each pair of the base angles are congruent. So again, if it's isosceles, then these two will be congruent, this will be congruent. Okay. And the reason is because this angle is facing this side, and this angle is facing this side. So if they are facing the same situation, they will have congruent angles. Okay? And since they are parallel, then this would be supplementary to this, and this is supplementary to that. So since the angles are supplementary to the congruent angles, therefore they are congruent. Okay, theorem 8.15. If a trapezoid has a pair of congruent base angles, so this is kind of the converse. Okay, if the base angles are congruent, then the length are congruent. okay? Because the length facing the congruent angles are congruent. Okay, so it says then it is an isosceles trapezoid. Okay, again, if the two angles are congruent, means the length, the leg that facing this and the leg facing that, because they are facing the congruent angles, therefore they are congruent. And because they are congruent, therefore it's an isosceles trapezoid. Okay, theorem 8.16. A trapezoid is isosceles if and only if the diagonals are congruent. So again, if the diagonals are congruent, then it's isosceles. Okay? Because if it's not isosceles, it means the trapezoid will be tilted to leaning one side more than the other, and then their diagonals will not be congruent. Okay? So again, if the diagonals are congruent, then it's isosceles. Okay, let's go to example 2. It says use properties of isosceles trapezoid. Okay, so arch. The stone above the arch in the diagram is an isosceles trapezoid. Okay, so giving its trapezoid. From measure of angle K, so basically you're looking for the other three angles. Okay, so it tells you that it's isosceles trapezoid. So if this is 85, this would be 85. Okay, because the pair of isosceles trapezoid would be the congruent. So this is 85, therefore this is 85. And now you go vertically, okay? So again, because these are parallel, so the consecutive angle will be supplementary. So it means 180. So use 180, so 180 minus 85 give you 95. So this is 95, and this would be a 95. Okay, now let's go to page 544, mixed segment. Okay, mixed segment means it's a segment connect to the midpoint of opposite sides. It says, recall that a mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. The mid-segment of a trapezoid is a segment that connects the midpoint of its legs. Because this is the midpoint, so these two are congruent. Because this is the midpoint, these two are congruent. Okay. It says the theorem below is similar to the mixed segment theorem for triangle. It says the mid-segment of trapezoid is parallel to each base and its length, and it's 1/2 the sum of the length of the base. Okay. So when you have a trapezoid, okay, so this is A, B, C, D. Okay, so what it's saying is that to find out the mid-segment, you average the two. Okay? So instead of writing it this way, I'm going to use a longer base first, and that's a reason for that. Okay, you will see in a minute. Okay? So MN will equal to, you average the two, so you're going to use the DC plus AB. Okay, so this plus and you divide by 2. Okay? So that's how you figure it out. That's the length. Okay? Now, there's a very important fact that is not in this book. Okay, I'm going to draw the diagonals. I'm going to label this P and label this Q. Okay, so the formula to find this length. Okay, so I'm going to label. So MN is this length right over here. Okay, so color code for you. Okay, so MN. So the long mid segment you add and you divide by 2. Okay. To find the PQ, you subtract and use a longer base, so DC minus AB over 2. So to find this over here, you add, you divide by 2 to get a long one. If you subtract, divide by 2, you get this one over here. Okay. 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 Now, what happens if you add these two together? What happens if you have a MN plus PQ? Well, let's see what happens if you have MN plus PQ. What will you get? Well, this way you will add this together. So you're going to get DC plus AB over 2 plus DC minus AB over 2, right? And so this will equal to, when you add all this together, this will cancel out. So you're going to get 2 DC over 2, and this cancel out. So MN plus PQ will equal to DC. Okay. See that? So the long mixed segment plus the short mixed segment, when you add, you get that. Okay. Now what happens if you subtract? What happens if you use MN? What happens if you use this minus that? Okay. What happens if you have an MN minus PQ? What will you get? Well, let's see. So MN is DC plus AB over 2 minus PQ is DC minus AB over 2. Okay? So this will equal to, you have to change the sign, right? So you're going to get DC plus AB minus DC plus AB over 2. And the DC will cancel out, so this is equal to 2AB over 2 and equal to AB. Okay? So you got, sorry, kind of messy all over the place. So MN minus PQ equal to AB. Okay? So again, those are interesting facts. So it looks kind of messy, so I'm going to kind of summarize again. Okay. Okay, so you got A, B, C, D. And this is M, N, P, Q. Okay? And so again, I'm going to just summarize what we had with all those calculations. Okay, so what we found is that MN, the long mixed segment, okay, this is equal to, you add, divide by 2. Okay, the PQ, the short one, is equal to subtract. So it would be DC minus AB over 2. Okay? And then when you have an MN plus PQ, this will equal to DC. So when you add this together, it will give you the long one. Okay? If you subtract, okay, if you use a long mixed segment minus a small one, you get the one on top. Okay? So those are important things to know. Okay? So again, this is not in your book, but it's good to add to your, to your collection of important facts and theorems. Okay. So now let's go back to the book, the example 3. So in the diagram, MN is a mixed segment of the trapezoid PQRS, found MN. Okay, so again, we know that this is going to be the average of the two. Okay, so you just add. So when you add, you get 40, divide by 2, you get 20. Okay, and that's your answer. Okay, so again, if you're looking for the long one, you add, divide by 2, you get that. Okay, and if you're looking for a short one, in this book does not cover that, but in some future situation, you might have to look for these. Okay, so again, to find this one, all you have to do is subtract, divide by 2. Okay, and if you were giving this 2, and you have to look for the other 2, right? If you're giving this 2 and you're looking for the base and the base, then you can able to get that. Okay. Okay. Now, let's go to page 545. Kite. It says a kite is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. Okay. So now you got all these shapes, right? Again, this is going to be summarized in the next section. But basically what happens is when you have quadrilateral, Okay? If you have no parallel sides, then it's a kite. If you have one pair of parallel sides, it's a trapezoid. If you have two pairs of the parallel lines, then it's a parallelogram. Okay? Again, it's going to be summarized in a later section. But over here, you have a kite. Okay? A kite does not, it is a quadrilateral have no parallel sides, but you have congruent, two pairs of congruent sides. So these two are congruent, these two are congruent. And it's named a kite because it looks like a kite. Okay. So theorem 8.18. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay. So again, if it's a kite, then the diagonals are perpendicular. If quadrilateral ABC is a kite, then AC is perpendicular to BC. Okay. And the theorem 8.19, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So if it's a kite, only one pair would be congruent. Now, these two are not congruent. Only this pair would be congruent. And the reason you get that is you draw a diagonal over here. So if you draw a diagonal like this, and you can prove that two triangles are congruent by using SSS, right? Because when you draw that you use a reflexive. So it would be SSS. And then after that, this two would be congruent because of CP-CTC. Okay, let's go to the example 4. Applies theorem 8.19. Okay, so from measure of angle D, you're looking for this angle over here, shown at the right. Okay, so if this is a kite, and this would be bisecting. Okay. Okay, so. Okay, so by the way, they will bisect because of the CP-CTC. Okay, so one way to do this is, and let's go and draw the kite. Okay, so this is 124. So that means it bisects, so this will be 62, and this will be 62. Okay, and this one is 80. So that means this is 40 and 40. Okay, and you're looking for angle D. So here's your, okay, let's see, this is D, E, F, G, and these two are congruent, and these two are congruent, okay? So again, if there's kite, it bisects the angle, okay? Now, it does not, you have to be careful, it does not bisect these, okay? It only bisect the, because of these, okay? So these two are congruent, therefore these two would be, angle would be congruent. Okay, so now the triangle equal to 180. Okay, so you use 180 minus the 2. So use 180 minus 62 minus 40. So measure of angle D equal to that. Okay, so measure of angle D will equal to so 78 degrees. Okay, and that's what you get. Okay. Now, the book do it differently. The way the book do it is a little bit safer, okay? But this is a little bit quicker. But you have to be careful. You have to know which angles are bisected, okay? These two are not bisected. The angle over here is not bisected, so you have to be careful with that. Okay. What the book did is, you know that in a quadrilateral, the inside angle equal to 360. So all four angles equal to 360, okay? And so you find, and also notice these two congruent, this angle is congruent, so that's why they use substitution, and they divide by 2 after that. Okay. But I like to do it this way, it's much quicker, but to do this way, you have to know which pair got bisected, okay? So the way to do it is very easy to remember, okay? See, these two have same marking, so this would be same angle. These two have same marking, so these two have same angle, okay? Notice these two are not the same marking, so these two are not same angles, okay? That's an easy way to memorize it.